Planets and satellites is a collection of geometry node groups that can help you make solar systems with multiple planets and moons easily. You can make planetary systems that are highly customizable and in a non-destructive way by enabling you to change any property like distance or orbit speed instantly. It works with Blender version 4.5 and later versions. Check the link in the description. Once you download the blend file, save it in your Blender Assets folder and use it directly from the asset browser. Let's get into how it works. I'm using Blender 5 for this. Let's delete everything and start with a fresh scene. We are going to need a container for our geometry node setup, so let's add in a plane. Now go to the geometry node tab. We don't need the spreadsheet for now. And create a new geometry node tree. We don't need the group input. We are going to create completely new geometry. Let's add in our node groups. Let's go to the asset browser. And here we have object text, planet and satellites. Let's bring them all in. So these are the node groups that I'm going to use. If you're using Blender 5, just make sure that in the preferences, the import method is set to append. Otherwise, by default, it would be set to pack. If it is set to pack and you import your node groups, everything inside would be disabled, so you won't be able to use it. Let's start with the first one, that is the planet. Let's plug the geometry output to the group output. And you cannot see anything, that's because first you have to provide a base geometry. So since we are creating planets, let's add in a UV sphere. You can also import any other geometry. You can just directly drag any object you want from the outliner and use that. Doesn't have to be planets. You can create any motion graphics animations as well. Now the next output socket is the orbit. So to see the orbit, we have to plug it into a join geometry. Give it some distance, and here is the orbit, but you cannot see it because there is no geometry. The orbit is based on grease pencil object. So first we have to bring in a grease pencil blank, and you can see we have an orbit trail. Now you can see the planet is already rotating and also orbiting the center. That's because in the rotation properties, we have a default rotation, and in the orbit properties, we have a default orbit speed as well. Let's begin from the top. So here we have an input for satellites. So anything that you plug in here will be a satellite of our object. We'll look at it later. Then we have equatorial radius and polar radius. For scaling, you're just directly going to change both of these at the same time. And let's say you have a planet like Jupiter or Saturn that has more radius on the equatorial side. So you can give it a slightly bigger equatorial radius. Let's just keep it the same for now. The next input is distance from center. So this will determine how much distance do we have from the center point. The next is time unit, which is either frames or seconds. With frames, the animation will be based on the number of frames, and with seconds, the animation will be based on time. So even if you change the frame rate, the animation will remain in the same speed. Now let's look at these hidden menus. The first is the rotation properties. Here we have rotation speed. So if you increase the rotation speed, the rotation will slow down. So it works inversely. Okay, we can't see it because it has too many segments. So let's reduce the number of segments. Okay, you can see that it is spinning slow now. And if I reduce the value, the rotation speed is increasing. So the closer it is to 0, the faster it will rotate. And if the value is in negative, it will rotate in the opposite direction. And again, if you increase the value in negative, it will rotate slower, and if you keep the value less, it will increase the rotation speed. With rotation offset, you can make your object wobble, and this is not how planets rotate. This is just if you want to make a wobbly planet or something. For now, let's just keep it at 0. And the next hidden menu is the orbit properties. So first we have the orbit speed, and again, just like rotation speed, it works inversely. The higher the value, the slower it will orbit. The lower the value, the faster it will orbit. And if the value is in negative, it will orbit in the opposite direction. Higher the value, slower the orbit speed. Now this is interesting. Orbit offset will enable you to change the inclination of the orbit plane. As we know, some planets, moons, have inclined orbits, which means their orbits are not aligned with the plane of the planets. Their orbit angles are inclined. So you can have that effect by changing the orbit offset. You can change it in X, Y, or Z. Let's bring it to 0. The next input is the orbit ellipse ratio, x is to 1, where the value is the value of x. Now if I increase the value, the orbit will become an ellipse. So by changing this ratio, you can change the orbit into an ellipse. And using the orbit offset, you can also determine in which direction the ellipse is facing. So some planets have elongated orbits. You can set that using the orbit ellipse ratio. Let's bring it back to 1. Now we are going to the next hidden menu, which is the axis properties. Now the first is show axis. If you click on it, you can see our planet has an axis going vertically through its center. So the axis is the line along which our planet or any other object will rotate. Now as you know, the Earth has a tilted axis, and the Earth's axial tilt is 23.5 degrees. So if I set it to 23.5, now you can see it is rotating along a tilted axis. So you can set it to whatever you want. And next option is rotate tilt. So you can change the direction in which the tilt is facing. The next option is auto rotate tilt. Now the rotation speed is too low, let's increase it a bit. Again, it works inversely. If you set the auto rotate tilt on, your planet will again, its axis will keep rotating. Again, which is not what happens in the real world. The planets actually are set at a particular axis. And again, you can change the rotation speed using tilt rotation speed. The next hidden menu is completely for trails. The first is trail resolution. So you can set the trail to be really detailed, like if you set it really high, the trail will have lots of points to create the perfect circle. And if you set it low, you can see the segments are showing. Trail profile radius will change the radius of the trail. You can make it thicker or thinner. Trail length, you can change the length of the trail. If you set it to 0, the trail won't be visible, and if you set it to 1, the trail will complete a full circle. And you can also set it further beyond 1. The maximum limit is 2. The next option is the trail color. You can change the color of the orbit trail using this. Now you cannot see it because you have to see it in the render view mode. Now you can change the color to a single color, or you can even set a gradient. So for that you have to use a spline parameter, add in a color ramp, connect the factor to the color ramp, and color to the color. Now you can see that there is a gradient going through the trail. Now you can change the color of these pins of the color ramp. You can even add extra pins. You can even flip the color ramp, and it will flip the order of the gradient. Now opacity reduces the opacity of the trail. You can also set a gradient on the opacity as well. So if I copy this and plug it into the opacity, reset the color ramp, now you can see that over here our value is transparent near the planet. So if we flip the color ramp, okay, now it's solid near the planet, and at the end of the trail it's getting transparent. The next option is if you want a full circle trail. So by clicking it, you can have a uniform circular trail. Okay, that's all there is to know about this node group. Now we can move on to our next node group, which is satellites. Plug in the geometry and orbits. And again we have to provide a base geometry. So I'm again adding a sphere. Also you can add any other object, doesn't have to be planets. Now satellites node can be used to create multiple satellites very fast. You can see if I increase the count, you can immediately increase the number of satellites. Okay, again let's see from the top. First option under the geometry is pick instance. Let's come out of the render view mode. Now if we have various objects, like this is a UV sphere, let's add in some more objects. Let's add in a cube, a cone, and if I use geometry to instance and plug all of these objects and plug the instance to geometry and click on pick instance, now you can see it is okay. Let's reduce the distance so that we can see what is happening. Now you can see that out of these three objects, it is randomly picking any one of these objects as any of the satellites. So you can add multiple objects and it will randomly distribute them. If I increase the count, you can see that it is randomly distributing these different objects as satellites. Count is for how many satellites you need. You can very fast add a lot of satellites. The next is minimum distance and maximum distance, which will determine what is your range along which you want to distribute your satellites. Then we have seed distance, which will randomize the distribution of these objects. You can pick any seed number and it will give you a random variation. Then we have minimum size and maximum size. If we give it a range, it will distribute your objects and scale them in between this range. Again you have seed size, which will randomize the sizes of these objects. Time unit works the same as it did in the planet group node. You can set it to frames or seconds. Now here we have again the hidden menu, rotation properties. Now let me reduce the number of segments on the cone and the UV sphere. Now the fastest rotation and slowest rotation will randomize rotation along different objects. Now you can see this cube is rotating faster and other objects are rotating much slower. Then again you have seed rotation speed. You can change the seed to any random number and it will create a random variation for the rotation speeds of these objects. The next hidden menu is orbit properties, and the first option is near speed and far speed. So we can change how fast we want the objects that are closer to the center to move and objects that are further away as well. So within this range, the objects will move at speeds that are ranging from near to far. And you can also do it in negative as well. If you go negative values, then it will orbit in the opposite direction. Now this is the most interesting property, orbit plane offset. If I change the angle, the satellites will randomly change their inclination, their plane of orbit. And this effect can be very useful when creating motion graphics as well. A lot of planets have moons that don't follow the planet's plane of rotation. Then we have seed orbit offset, which will randomize the offset of the orbits. The next option is orbit ellipse ratio x and ratio y. So just like planets, you can randomly give these objects an elliptical orbit. A ratio of 1:1 will give you perfectly circular orbits. Okay, the next is seed ellipse ratio. So you can even randomize the elliptical orbits by changing the seed ellipse ratio. Let's set these values back to how they were. Lastly, trail properties. So these options are similar to the planet group node. You can set the trail resolution to how much detailed you want your orbits to be. Then we have trail profile radius to increase or decrease the thickness of your orbits. And trail length, you can set it to 0 or the maximum would be up till 2. Then we have options for color and opacity, which again you can set it to a single color. Let's switch on the render view mode. You can use gradients for color just like you did for planet group node and for opacity as well. The last option is full circle trail, which will give you uniform circular orbits. And that's it for the satellite group node. Now let's see how to use object text. Object text can be used for labeling these objects. Like you can show the name of this object on top of it as it is orbiting and rotating and all that. Now here I have set up a planet node which is orbiting around the center point, and I want to display the label, the name of this object on top of it. So get the output from the join geometry, put it in the geometry input socket, and use another join geometry. And in the string input, write the name of your object. Here I have set up a camera, so this text will always be facing the active camera. So if you look through the camera, you can see that this text is facing towards this camera. Now let's give it an offset. If I give it an offset in the Z direction, it will move up in the Z axis. And if I press play, you can see that the label is moving along with my object. So you can reduce the size, increase it, you can change the position, and you can rotate your text as well. And if you want to change the font, you can also go inside the object text node, and here you have a string to curves node where you can change the font style or spacing of your text. Now let's see how to create a simple sun, planet and moon system. I'm going to use the planet node to create sun, planet and the moon as well. So I'm going to duplicate this node twice. Now this will be my sun, this will be the planet and this will be the moon. Now the center object is going to be my sun. Now let's create our planet. I'm going to use the UV sphere, plug this into the geometry, add in a join geometry, and I'm going to create a join geometry for this planet itself as well to plug in the geometry and orbit. Now plug this join geometry here and give it some distance. Now the planet is obviously going to be smaller than my sun, so I'm going to reduce the radius. Now this is my planet. Now let's create the moon, which will be the satellite of this planet. Using a sphere again, plug in the geometry and orbit, and this time plug the join geometry into the satellite socket of the planet. Give it some distance and obviously reduce the size of the moon. It's going to be smaller than the planet. There it is. And since we want the moon to orbit faster than the planet, let's increase the orbit speed of the moon. And to create the label of these, I'm going to create a separate object. Now I added in a new plane, create a new node tree, delete the group input. Now I'm going to import this plane object which has this entire sun, moon and planet system. Use relative and bring in the object text. Duplicate it twice. Now plug this geometry into the input sockets and plug them all into a join geometry. And let's name them sun, planet and moon. Okay, they are all inside the sun right now, so give them an offset. This is our sun, this is our planet. Change the index number so it will switch to another object. Okay, now it's on top of the planet. You can reduce the size of the planet text. And for the moon, change the index number and reduce the size. Give it an offset. Now if you look through the camera, all the text is facing the camera. And since we have created different objects, we can either turn them on or off as well, directly from the outliner. Here is an example where we have a sun and two planets, each having its own moons. So let's look at the node setup. First we have the sun, which is just a simple object in the center. You can use the set material node before plugging it into the geometry input. Then we have planet 1. It has two moons. So this is the main planet. And these are the two moons. So I have used two planet node groups, plugged them into a join geometry and connected to the satellite input of the planet. And this is the second planet. Here is the second planet. Here we have the geometry for the planet, and for the moons I have used the satellite node. Here I have kept a count of 4 satellites, and they are all orbiting this planet. So you can create multiple planets having multiple satellites. You can also apply the smooth by angle modifier to make sure that your objects appear smooth. And this is the object for the text. You can turn it off if you don't want to see the labels. And here I have simply imported the object which has the solar system, and then each object text has a different index, and if you change the index, the particular label will move to a different object. So there is an object text for each planet or moon, and each one has a different index number. You can also apply the set material node at the end of the node setup to give your text objects a nice shader. So using these node groups, you can create an effective system of planets, moons, and make your own interesting solar systems. One last important thing is while rendering, always make sure the depth pass is turned on, as the orbit trails are crease pencil objects. Otherwise, they would show up on top of your objects. Alright, so go on and make your own interesting planetary systems, or you can even replicate our own solar system. Thanks for watching, and here is some more interesting stuff from Point Scatter.